All right, welcome back. In this video, we are talking specifically about network architecture. This is about how networks are connected together. We'll talk a little bit about LANs and WANs, and then we'll talk about the internet. First up, what's the difference between a LAN and a WAN? You've heard local area network. That's what LAN is. That probably, when you heard it, you probably heard someone call it as a small geographic area. So that might be something like the small network inside my house, local area network. You also might have heard wide area network, so WAN, as being a big network. So that might be like Verizon's network, nationwide network, or the Cox network in Norfolk. It's pretty big, right? So that's basically true, but I want you to know how networking professionals think about LAN versus WAN. A LAN is what we call the networking equipment that we use to transmit data within our organization's sites. So yes, my house is a LAN because all of the devices in this house are within my house. So that's a LAN, right? The more precise definition, though, is the cabling and equipment within my house is owned and controlled by me. So that makes it LAN for me. Everything I own and control in my site is considered LAN. So if you look at this diagram again, you'll see large office building. That's a LAN typically because the organization controls the entire building. Inside, for example, a bank's branch office, that equipment inside the building that is owned and controlled by the bank's IT department, networking group, is LAN. It also includes even larger geographic areas. So if you think about a campus, like an organization that has multiple buildings that are separated by a fair amount of space, a lot of that might be LAN, and in fact, all of it might be LAN. If you think about ODU's main campus, where all the buildings, that are connected between, on ODU's campus, ODU owns and controls all of that equipment. So, according to the IT people that work at ODU, that would be considered LAN. Now, how do we go to WAN then? Well, WAN is what we use when there's a place or somewhere between our sites that we're not able to put cabling in. It's usually almost always cabling, in fact. And so it might be that the distance is too far or that we're trying to go across someone else's property. In that case, we need what's called a carrier, okay? So the WAN technology is that stuff that's owned by the carrier, and we as an organization are paying to use it. Now, we don't control it, we don't own it. The carrier owns and controls it, and they provide that service for us. So this happens again. The organization may not have the money to run cable for a long distance, or they don't have permission to run cable across someone else's property. These carriers get that permission, and so they provide the WAN service. So the carriers are needed to carry these signals between our premises. So if we have various sites, a carrier is going to be the thing that connects them between them. So just a couple of terms I want you to be aware of. One of them is a right-of-way. A right-of-way is a government permission to lay wire. So, the city of Norfolk, for example, can give Cox permission to lay wire within the city. The city has what's called an easement. Usually it's in if you look at someone's house, it's the area between the sidewalk and the street, or in the street, that the city can give these carriers permission to lay wire. They put the pipes in there too. So that's called a right-of-way. So that's, I guess, the main thing we're trying to talk about. Make sure you understand the idea of a carrier, that the carrier is the one who owns that equipment, and that the the final thing is a WAN link, which is what's going to be the actual link of what you see. So a given organization that has multiple sites might have multiple WAN links. They might also contract with a carrier to provide all those WAN links. So if you think about ODU's main campus, They also have links out to their satellite campuses, for example, Virginia Beach, Portsmouth, one on the peninsula. And so they might have a contract with, say, Verizon to provide all of those WAN links. Now, so thinking about the networking professional within the organization, when they think about their, quote, network, their network consists of all the LANs, so all the LAN equipment, all the LANs in their network, and the WANs. So all the WAN links that link together all the LANs, that all combined is the organization's network. And the basic idea, again, is the combination of all the LAN and the WAN links make a network for us, and that means an application on any host can communicate with any application on any other host on any other subnet in our network. Okay, so we got a lot of gluing we need to put together. This same gluing applies to the internet. Now, the internet is just a network of networks, and in fact, it's a network of subnets that are just glued together, and there might be hundreds of them. So I can show you this diagram here, and it might be, for example, my computer at my house, and I have an access line into a switch, or let's say it goes into the Cox network via a router. You know, you all have one of those Wi-Fi routers at your house, right? Cox also has routers that glue them to other carriers. So the ISP, my ISP is Cox. Cox also has ISPs of all things that might be on the backbone. So this might be Verizon, AT&T, there's various backbone carrier providers. And if I'm trying to connect to Facebook, my traffic, my messages are going to go across the Cox network, across those backbone networks, then into whoever Facebook's ISP is, and then finally to the Facebook servers themselves. So this is all just glued together, and honestly in this class what you're going to find out is how to set up the internet, because it's really, when you get down to it, it's just kind of like Tinker Toys almost, and you have to know the right things to plug in. So this is the basics of network architecture. Like I said earlier, the network architecture is part of that plumbing, so users do not care about this, okay? But you need to. If you're a network analyst or a security analyst, you need to understand how all these parts work together. Thank you, and we'll see you next time.